Good morning, Professor. My name is Zhenming Hu, and my project is about the sentiment-based prediction of CNY to GBP exchange rate. Now I will explain my project to you. This is the directory of my slide. It's similar to the structure of my thesis. The foreign exchange rate is the conversion ratio when converting a currency to another, and reflects the value between the two. The foreign exchange market is one of the largest financial markets in the world. Due to political, economic, and psychological factors, fluctuations in foreign exchange rates can take place, bringing trading risks to individual investors and businesses, and eventually affect a country's economy. Therefore, forecasting foreign exchange rates is of great significance, and accurately doing so has become one of the major topics in the foreign exchange market. In my project, a prediction system was designed for foreign exchange rates. It combines foreign exchange quotation data and foreign exchange opinion data as input, using the mining and analysis of unstructured opinion information to improve the accuracy of foreign exchange rate prediction. I believe that combining foreign exchange rate information with related news can result in information gain, thereby achieving better prediction performance. The main tasks of my project are: first, review the research status of sentiment-based prediction of financial markets. Next, design a sentiment-based prediction model of foreign exchange rate, and then implement the designed prediction model. Finally, evaluate the implemented prediction model. And measurable outcomes are sentiment-based prediction model of foreign exchange rate, code implementation of the model, and evaluation for demonstrating the results of prediction. Next, I will introduce the background of my project. The data I used came from public websites on the internet, and I used crawlers to store the data locally. I used the natural language processing techniques to transform foreign exchange opinion information in the form of text into digital feature vectors that can be directly processed by computers. Recurrent neural network introduces the concept of time sequence and directed cycles. When it decides, it considers the current input and what it has learned from the inputs it received previously. PyTorch's flexibility does not come at the expense of speed, and in many measurements it outperforms frameworks like TensorFlow and Keras. Most of the existing methods are based on the historical data of foreign exchange rates in numerical form. I proposed a sentiment-based method which also treats the foreign exchange opinion data as part of the research object. Next, I will introduce the design and the implementation of my project. The raw opinion text data must be converted into numerical feature data usable for model training, validation, and testing. I first performed the part-of-speech tagging operation to select the feature words from the specific part-of-speech labels. Next, I compared each foreign exchange opinion data with the feature set and deleted the opinion news that did not contain any feature word. For the feature representation, I conducted the sentiment analysis on the filtered opinion data individually to derive the sentiment score of each news to all feature words. Then I adopted an accumulative method to sum the columns of the feature vector corresponding to each opinion news within the same day to obtain the final daily feature vector. I implemented the main research model by LSTM using PyTorch. For comparative analysis, I also used it to implement unit LSTM and artificial neural network. In addition to directly predicting the exchange rate, I modified the basic model to make it predict the differences in the foreign exchange rate. Moreover, I also performed the prediction for the classification problem of whether the exchange rate would rise or fall. Next, I will introduce the results and the discussion of my project. For the evaluation criteria, My project involved mean square error, mean binary cross entropy, and accuracy. Based on experience and constant debugging, I allowed the model to train for at least 30 epochs. Afterwards, if the MSE on the validation set for 9 continuous epochs appeared to increase instead of decrease, then the training of the model was brought to a halt. At this time, the training result of the inverted 10th epoch was the best model state under such a combination of hyperparameters. I applied it to the test set, and the results are detailed in this figure. Contrary to expectations, the bidirectional design does not allow the LSTM model to obtain a smaller loss on the validation side than the unidirectional design, and the bi-LSTM model has a particularly large increase in loss on the test side. For the exchange rate difference prediction model, I performed similar operations, and I also applied the best model state to the test set, and the results are detailed in this figure. Surprisingly, the three models are amazingly similar in terms of both the hyperparameters and the losses on the datasets. The bi-LSTM, uni-LSTM, and AN models all have essentially the same predictive power and generalizability in the problem of sentiment-based prediction of foreign exchange rate differences. For the exchange rate trend prediction model, I repeated the previous operations. According to the confusion matrix, the accuracy of the prediction is 52%. This table refers to the prediction accuracies corresponding to the three models. Next, I will introduce the conclusion and further work of my project. The LSTM model is a superior algorithm for predicting time series data, and I demonstrated its high usability for the foreign exchange rate prediction problem. I also repeated the experiment using multiple currency pairs. The inclusion of foreign exchange opinion information did not significantly enhance the accuracy of foreign exchange predictions, and the model results were quite unstable, and the generalizability was low. For the data itself, I also covered that websites like Sina Finance and Wall Street have similar data. Integrating more data to fully cover the foreign exchange domain may lead to many exploration results. Using several methods to transform unstructured foreign exchange opinion messages into feature vectors is also a direction worth continuing to explore. Moreover, varied numbers of feature words could be explored as a hyperparameter. The model itself is also a direction worth investigating. Trying other RNN models is a promising area. Thanks to all the teachers and students who helped me during the project. This is the whole content of my presentation. Thank you.